Okay, continuing, and some of you, at least some of my Finnish friends, I think will recognize this song. Okay, as you can see, the piece is now set up in the rotary table in the milling machine, and I have centered it to the center line of the rotary table. And the centering is done within 200ths of a millimeter, and I cannot get it any closer than that. I guess it's most probably a problem with the rotary table itself or the surface finish of the board. Let me show you. And while I'm speaking, Finland is taking on Belarus, and so far I think it's not going very well. We don't have the channels to watch ice hockey because they are very expensive here, so we are using the radio to listen. Okay, now let's center the piece to the spindle of the milling machine. Okay, now centering the piece and the rotary table to the spindle of the milling machine. And by the way, if you're wondering why my voice is like this, I don't have a cold. I have an allergic reaction from a birch tree, which really sucks. And it's very weird. I think I was 21 or 22 when I got the allergic reaction for the first time, and now I'm 24, so I've only had it for a few years, and before that I've had nothing, no allergic reactions at all for any tree or anything. So it just suddenly popped up, and I've had it every year since then. And it's very weird because I've always lived in a little bit of a countryside near trees and nature and everything, so I really have no idea how it's possible that I got it, but here I am. It will go out in a few weeks, hopefully. Okay, now let me show you a little bit of centering. I will speed this up. Okay, now we are within 200ths of a millimeter, close enough, and now zeroing the digital readout. Okay, the piece is now centered, and what I'm gonna do now is I'm gonna drill 2 bolt circles on this face right here, and the circle of the bolt patterns will be 5 times 120, and the other one will be 5 times 114.3 millimeters. So I guess I'm gonna do the 5 by 120 first. So how I'm gonna do that? It's very simple. I'm just gonna move the x-axis offset to 60 millimeters. Okay, let's do that. Okay, and this is where I'm gonna lock everything. And the only thing that's gonna move from now on is the rotary table and the quill of the milling machine right here. Okay, here goes in a 14mm drill bit in an ER40 collet. I'm not gonna drill any pilot holes, just using this drill bit to go through. Okay, we're tight now. Changing gears. I guess we will go with 280 RPM. Plenty slow, but I like that. And I'm gonna use some cutting oil. I'm not gonna use the flood coolant. I'm not gonna use, for a single time, I'm not gonna use this flood coolant anymore on this machine. It's so dirty. It just makes everything rust, and that's terrible. I must change it soon. But the very first thing is to oil the Z-axis ways with an oiling pump that's located on the side of the machine. And you can see there's still a little bit of surface rust on the ways. Let me show you right here from the moving and storing outside for 2 days. But the table doesn't go that much, it doesn't travel that high, so I haven't gotten into scraping off the rust, but I will do it someday soon. But now let me just pump some oil. And by the way oil I'm using, it is that heavy grade 680 hydraulic, gear oil, and I have mixed in some diesel fuel, so I'm now using it for whey oil. I think it does a pretty good job. At least it's extremely sticky, which I think is good for whey oil. Okay. And you know there are oil channels going through all the way the knee ways. So it's not just spraying oil from these seals, it's also sending it down. Okay, now let's move the Z-axis up a little bit. Okay, I think that's good enough. And we are still at X60 and Y0 and Z error, because I still haven't attached the Z-axis scale. I have it, but I still haven't gotten into installing it. Okay, and how I'm gonna do this? It's gonna be 5 holes, 72 degrees apart from each other. So I'll be using, for quick reference, I'll be using the numbers right here on the outside of the rotary table, and for the last few accurate minutes and seconds I'll be using this scale right here, which is very accurate. Okay, we are all set to go. And I will first use only the manual feed, and let's see how it goes, and then maybe switch to automatic feed. Whoops, have to tighten the rotary table also, almost forgot. Okay. Okay, here we go. First hole. And now going for the first 72 degrees. And by the way, my zero mark is here and my reference mark. So let's go. 72 degrees. I hope I don't hit my clamp. Looks like I will hit my clamp, of course. That's not very good. Okay, I think I will skip this hole and deal with it later somehow. So the next one is 142 degrees. I mean 144 degrees. Not true. Okay, on the next hole I will have to break the chip at some point. Okay, this is how I'm dealing with the clamp hitting the drill or the drill hitting the clamp problem. Can you guess where the view is from the camera? Let me show you. So, luckily I had set up the rotary table in this manner, so it's in an angle to help this hand lever hitting this control box. So I have one fastener here on this T-slot and the other one is on this T-slot right here. So I have the center T-slot free. So I use the view of my camera and a flashlight to see inside that hole, because I cannot get my head between here. And I slid a T-slot nut right here under the rotary table, and it is now I can now reach it through the whole of the work and through the whole of the spindle of the rotary table. And now I'm gonna give it a clamp like this and a bolt through here. And I think I will have to remove both of these to prevent the piece from rocking, from having pressure on just one side. Okay, this is my glorious setup, and as you can see, the problem with this of course is that I cannot turn the rotary table when I have this tightened. But that's okay, because before I did this setup I went back to 72 degrees where my last hole will be. And actually, as you can see, I was able to move the clamp a little bit further. It's still barely just at the end of the piece. So I guess I could now take this one away, but since I now got it set up, I think I will keep it. At least until I have finished this hole, and maybe then I will do the second operation for this hole, and then I will move this back closer and then remove this one. But now let's go for the last hole. Okay, the last hole is now drilled. I forgot to switch on the record, but you already saw 4 holes, so I guess that's enough for you. And by the way, this would be the easiest to do using the hole pattern calculator on the DRO, but I have never used it and I have no idea how to use it, and I cannot learn it because I have the manual still at my old workshop. I think that would be a whole lot easier than setting up the rotary table. Okay, a few days have passed and the last hole is now drilled, and I still have to remove the temporary clamping right here. But when that's done, I'm gonna start using these. Actually, I cannot recall what's the name of this tool, but the diameter is 20 millimeters. And let me show you the studs. The studs are like this. This diameter here is around 14.5 millimeters. So actually, when I did the previous hub, I used a 14 millimeter reamer to ream these holes for the knurled parts on the studs, but they were really tough to press on, so I was only using a 14 millimeter drill with having hopes to have the holes actually a little bit larger than 14 millimeters. And I still haven't measured the holes, but I think I now got them a little bit larger. And something has also happened that I'm extremely happy about. I've been about to do it for a very long time, and check this out. No more error. Woohoo! It's working. The Z-axis scale is working, which is awesome, great, awesome. Okay, I had it apart maybe 1 or 2 years ago actually, and the scale is now here and the reader is also here, of course. And I think the problem was right here, and there was one cable that was cracked a little bit, so maybe that was the problem. And another cause might also be the scale just being extremely dirty. Because it's missing one of its wiper rubbers right here, so it's a very old scale, but I'm just trying to keep it clean now. I also tried to locate a new scale, but they really cost a fortune. But maybe if you know where to get these Sony Magna scales, I might be interested in one, or maybe even a few more. But for now it's working, and that's just awesome. And soon I also want to learn a little bit more about this DRO. It has very, very many functions that I have no idea how to use. Okay, but very excited and happy now to have it working. Okay. And even though this is a pretty old scale, I think it's from the early 90s, it should be pretty modern with quite a few functions. And I think this was also one of the most expensive DROs available at its time. Okay, but now let me get back to this project right here. Okay, I got my memory back. This tool is called countersink, of course. I think all of you already knew that. So what I'm gonna do now, I'm gonna zero to the face right here, and then I'm gonna feed down 18 millimeters using my finally working Z-axis digital readout. Okay, again first oiling the ways a little bit, and then we are ready to raise the table and find the 0 point. So let me slow down the RPM. I think I'll be going at the slow speed, let's say 140 RPM. First let's find the 0 point. I think there is a possibility to run the feeds without the spindle running, but I haven't found that option. So for now I just have to run the spindle whenever I want to work the feeds, and that kind of sucks. It is working. Oh. Okay, the rest of the feeding I think I will do with the quill. And this countersink is meant for 14mm holes, and the guide piece in front of the tool is also a 14mm. But since I'm going slow, I have found that these actually work extremely well, even without the guidance of the pilot hole. So here we have a 0, and now feed down just a little bit by hand. And what kind of feed should we use? We have 80mm per minute, and I think I'll first try halving that. And if it goes easily, I think I will bring it to the full 80mm per minute feed. Okay, let me get some cutting oil. Let's see what happened to my oil can. This is supposed to be pressed on here. You can see the pressing marks right here, but it just came loose. I hate cheap tools. Need to get a proper one. Okay, let's just hope it works for now. And this is a pretty noisy gear actually. I hope you can still hear me. Nice chips. Okay, I think that went pretty good. Now let me remove the temporary clamper right here and move to the next hole. Okay, now moving to the next hole. And we are at 72 degrees at the moment, so let's go this way. It's 144. 72 times 2 is 144 if I am right. I hope I am. So I really should get my vacuum cleaner here. Okay, let's go for the next hole. Okay. It makes a nice bird's nest, even though I try to break the chip. And again, I tell you not to do this with your bare hands like I do. So, now for the next hole. I think I'm not gonna show you any more of these. They will be just like the two first that you just saw. So, I'll show you the next step, which will be drilling some more holes and tapping them. Okay, I changed the tool to this 10.5mm drill for M12 threads. And since there's gonna be two 5-hole bolt patterns in this piece, they have to be, the holes, the next holes will have to be in between these holes that I have already done. When these holes are 72 degrees from each other, I will start this whole whole circle with 36 degrees. I think that's half of 72. Let me recheck. And also the diameter of the bolt circle is different than the diameter of these ones. So I will have to change my x-axis setting, and I guess I will do those things now. But first, by the way, let me show you something that I got this morning. Sandvik Coromant. Turning tools and milling tools and spare parts and technical manual. This is a great book. This is an awesome book. I think I might say a few words about it in one of my videos. And I actually also ordered one tool holder and 2 sets of inserts. Actually, I have to say that turning tools were not as expensive as I thought they were, and I actually got some pretty good discount for them also, so I had to be happy. Until now I have got all of my tools from flea markets and auctions and like that, second hand and old stock. But from now on I will try to buy my tools new, because then I get exactly what I need and not just what there's available. So actually I ordered a CNMG turning tool with a 25mm or a 1-inch shank, and I took 1 box of finishing inserts and 1 box of roughing inserts. I'm pretty excited about that. I'm gonna get them next week. Okay, so let's get back here. Okay, let me reset. Okay, so the bolt circle diameter is 114.3 millimeters. So that halved is 57.15. Looks like it moved 1/100, but that's not gonna matter. And I have my drill set up, and I have the rotary table at 36 degrees. I'm gonna lock it. And I think we are ready for the first hole. Let me increase the RPM a little bit. Let's go 400. And also I think I will first try 80 millimeters per minute feed because it's already set up, but I think I will increase it. But let's first try with this feed. Okay, let's start. This is a cross ground drill bit, so I don't I don't drill any pilot holes. Okay, now ready to do the tapping, the threading, and I have set 50 RPM, and this is M12 12 by 175 millimeter tap, and it's a new tap. I've never used it, and it should be pretty good. It's made by Boss. So I got 50 RPM, and which is the slowest speed on this mill, and I'm feeding the quill down by hand as the tap goes deeper into the hole. And it's a little bit. This machine is not very good for tapping, because the leverage system is so tight that the tap itself cannot pull the quill down. So I'll have to aid it by hand. A Bridgeport would be ideal for power tapping, but I have used this before for power tapping, and it works, but it's a little bit hazardous. So let's see if we get a broken tap or something like that. Okay, let's give it a go. The the speed is very low. Some oiling. And this tap is for through hole, so it's pushing the chips. Okay. Here we go. So you won't see any chips because they're going down. So far so good. Not enough space here. I cannot actually. Oops, I was really close here also. So I'll have to hand finish the threads, maybe with another tap. Okay, let me change the spindle direction, which is also a little bit difficult to do because the switch is behind the machine. Okay, we made it, but as I said, I'm gonna have to hand finish the threads. Okay, here you can see the finished wheel hub twins. So this is the one that I finished today, and this is the one that I finished 1.5 years ago. So this is how this looks like. I think I will do some chamfering to the holes on this side. I already chamfered the holes on this side, just by hand. So I think it came out pretty nice. And as I said you earlier, I will do some lightening to these because they will go in a race car, so they really have to be light. But I can remove material from here, for example, all around these or maybe around these, and take everything else out, because this is the side of the rim and the other side is for the brake disc. So both sides can be relieved around the bolt holes. And also I think I can reach inside there and remove some material. But and that's after the test fits have been complete. But for now, I think I'm pretty happy. I've been waiting a long time to finish the wheel hub, and also the customer has. And looks like I have one extra stud. Okay, that's good. Okay, thanks for watching, and I hope you liked this video. So until next time.